Good morning, everyone, and welcome to today's webinar sponsored by Rootstock Software. This is the first webinar in our ERP 101 webinar series. Our topic today is Introduction to ERP for Manufacturing and Distribution. Moving on to some housekeeping. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your own computer desktop in the upper right corner. You're listening in using your computer speaker system by default. If you prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. All attendees will be on mute throughout the presentation. You'll have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. I would now like to introduce our presenters, Pat Garrahy, founder and CEO of Rootstock Software, and David Bush, Senior Marketing Consultant at Rootstock Software. Pat is the founder and CEO of Rootstock Software and has 40-plus years of manufacturing and MRP, ERP systems experience. Pat was the founder and CEO at Relevant Business Systems and was previously at Martin Marietta. David is a Senior Manufacturing Consultant at Rootstock Software and has 30-plus years of manufacturing and MRP, ERP systems experience. David was previously at General Microcircuits, Consona Corporation, and Relevant Business Systems. Pat will now introduce us to ERP for manufacturing and distribution. Hi, Pat.
Thank you, David. I'd like to take a few moments and talk about this webinar series. This is a 10-part webinar series that will focus on manufacturing and distribution, ERP. As we all know, there are other ERP systems today, not just for manufacturing. There's ERP systems for retail, professional services organizations, banking and financial management, even higher education. But the genesis of ERP was manufacturing, and it is helpful to know the history. So we'll touch upon the evolution of ERP from MRP and MRP2, which are terms that you will find within manufacturing ERP systems. We'll describe ERP in simple English, and it will not be a highly technical description. So there's three key concepts or topics before we dive into the subject of David Bush's presentation today, which is MRP and ERP. So before we go into ERP, the three topics that we want to talk about are, number one, organizations, number two, four key terms, and number three, the history or evolution to ERP from the manufacturing systems that were predecessors to ERP. So I could have had a common thread that I wanted to use for most of the audience so that they could correlate a sample organization to the organization of a distributor or to a manufacturer. And that's why I wanted to talk about the organizations of a manufacturing and distribution company. And it allowed me to bring that thread or that string forward when I talked eventually about ERP. There's four terms that you will be hearing often today. BOM, which is bill of material. MRP, which is material requirements planning. MRP2, which we'll discuss later, and ERP, enterprise resource planning. And then finally, a little bit about the history, the evolution of what they call BOMP, or bill of material processor, to MRP, to MRP2, and to ERP for manufacturing. The first topic I want to discuss today is the organization of a manufacturing and distribution company. And we'll start with the departmental structure of an organization that I'm sure you are all familiar with. Then compare that one to one of a distributor and then manufacturer. So I thought I'd start with a typical software company. Most of the attendees of this webinar are familiar with an organization of a software company. Each one of you probably can conjure up an organization chart or a departmental chart, which includes things like engineering, where you design and develop the software, the administration department, the finance department, marketing, sales, and eventually some of the infrastructure like IT or customer support or human resources. When you look at a typical distribution company, there are many types of distributors which buy and package and distribute or ship. There's a food packager, electronics distribution like Avnet. So correlating that to a software company, you can just say there's no engineering. So there's no building of a product. There's just buying of the goods from a manufacturer, repackaging it, and distributing it. And then there's a lot of substantive departments and functions that you will find in a distribution company, more so than you would find in your typical software company. For example, there's material control, which does the planning and controlling of inventory, which tells purchasing what to buy and when, based upon a plan or based upon a sales requirement. There's the purchasing department themselves, where the buyer will get requisitions from the material control department, or in some cases, get it directly from the customer sales order, and then creates purchase orders, tracks them, selects vendors, unless they're already predefined. Then if those goods aren't drop shipped to the customer, they're received into inventory, and those purchase receipts are put into stock and then eventually shipped out to the customer. If there's any return material, they may process the RMA, or it may be sent back to the manufacturer for service. And finally, cost accounting tracks the cost of all the material movements, and those material movements being in receiving or inventory or shipping. So a typical manufacturing company, it's everything that a distribution company is, and in effect, two additional very important departments. There's, of course, the engineering department, which defines the product that you're going to build, defines the bill of material and the parts masters. And there's also the production control department, which is responsible for the manufacture and assembly of subassemblies and the production on the shop floor. So topic number 2 are 4 terms you'll be hearing often. And I'm going over these topics or these concepts so that it better prepares all of us for David Bush's presentation. And there's the bill of material, the MRP, MRP2, and ERP. So when you think about a bill of material, the first thing you think about is the end product. What is the finished product that you're going to build or assemble? Think of a bicycle that we'll use throughout this webinar series being manufactured or assembled, in our example, and eventually sold. Then there's a representation of this end product. And this is a drawing of all the bicycle's component parts. And usually this may comprise a number of drawing sheets, but in this simple example we'll only show you one. And then there's the bill of material representation itself. And we provided a very simple representation of some of those components. To further expand on the multi-level BOM or bill of material, we'll take that simple material and show it level by level. And why go into this? This is an easy manner by which to depict that which we buy, manufacture, assemble, or even sell. For example, this top level of this bill of material is the bicycle, which we'll assemble and sell. The next level depicts those components that are used in the assembly of the bicycle. In this particular illustration, there are 5. You can see the frame, the wheel, the control, the accessories. And then the next level depicts more of the components used in the manufacture, and specifically in the assembly of the wheel, which are the spokes, the wheel tires, and wheel rims. In this example, the components that are in orange are purchased. And the wheel is a sub-assembly which is assembled on the shop floor. And the bicycle is the end product, which is assembled or manufactured on the shop floor and then eventually put into finished goods for shipping. Going down these levels is often referred to as exploding the bill of material. The MRP program, which we will briefly touch on, has logic that processes each one of these levels, looking at the requirements and determining what work orders and what purchase requisitions to create. So here's MRP or Material Requirements Planning MRP2. I'm not going to go into these definitions. They're all available on the web. Basically, they all say they're all consistent in the definition. But suffice it to say, MRP is a program in these systems. But it is also the software modules that were sold in the 70s, of which the MRP program was but a part. And software companies that developed and sold these programs were called MRP companies. And then in the 1980s, the MRP2 concept was developed. And MRP2 is not necessarily an embellishment of the MRP program. But what it connotates is those MRP companies that actually added modules to their MRP program, and that system set became known as MRP2, which again serviced more of that organization than the MRP modules did. So let's go through a very high level view of the MRP engine or program and correlate that to documents and organizations and records. First of all, the first thing is the sales orders, which are managed by the sales department, which denote that which is going to be sold to the customer. So for example, on a given sales order, let's say it came into this particular company and they were going to sell to a customer 5 bicycles. So there was an order, a sales order for 5 bicycles due on a certain date. The engineering department is responsible for the design and maintenance of the bill of materials. And again, in this example, it's the bicycle. Now those are fed in as records to an MRP engine or an MRP program. So this MRP program will review sales orders, will review the bill of material, and these are the inputs. And now it starts to process its logic level by level. So for example, the very first thing that it does is generate a work order record for the bicycle. And further down in the logic, it'll generate a work order or work orders for the wheels to be assembled. All of this is managed by the production control department. The purchase requisitions for the component parts are managed by the material control department. It's their responsibility to decide when, in effect, to firm these requisitions. And within a certain time frame, they will firm them, and then they will pass them over to the purchasing department, and those buyers will select vendors and transform those material requisitions, those purchase material requisitions, into purchase orders. And then those purchase orders, the material will be received as purchase receipts. They'll go into inventory. They'll eventually be shipped out to the customer. In effect, this process that I just described is what they call a closed loop ERP, or MRP. And now the concept of MRP2. In the 80s, remember I said that the MRP companies started to develop more business functions to satisfy the rest of the organization. So really MRP2, the first modules of MRP2 were accounts receivable, accounts payable, general ledger, as well as sales order management. And then there was standard or average costing, which tied it all together. And that was MRP2, and that was in the 80s. Now in the 1990s, there was a term that was coined, and it was ERP. And it was to represent the software that would service all of the departments. Not only the ones that we have talked about up to this point, but other departments, HR, administration, marketing, time and billing, payroll, things like that. And so all of that combined was an enterprise resource planning, but it was for the business processes of the entire company or the entire enterprise. And again, this was in the early 90s, so they were thinking of a manufacturing organization when that term was defined. Topic number 3 is a brief history of the time from BOMP to MRP to ERP. So this is the third of 3 topics that I'm going to cover before we get to David's presentation. In the 1960s, IBM released a bill of material processor called BOMP. In effect, what that program did is it took the bill of material structure and exploded it. Now, this was in pre-mainframe days, so the computer hardware at that time could only process a certain number of records. But this BOMP program didn't explode or gross requirements of what to buy and what to build. So for example, if you take the bicycle, the BOMP program may say, what are the requirements for 5 bikes? And it would go down into all the components, and it would give you a parts list of what you were to buy. At that time, they really didn't do any consideration of inventory. It was just a raw program. And then in the 1970s, MRP goes mainstream. It was now built on mainframes. So the mainframes that came out were equipped enough to be able to handle more modules working together. A term was coined, commercial off-the-shelf packages, or COTS. And prior to 1975, most of the large organizations had a data processing department that built their own software, developed it for themselves. And soon, mid-70s on, there were a lot of commercial off-the-shelf packages that started to come into play, MRP being one of them. Actually, this was my first encounterance with MRP or software. I was one of the primary developers of a set of modules they call them MRP modules for Martin Marietta, but in effect these modules were bill of material engineering, inventory, shop floor control, which also did scheduling and capacity planning, a standard cost roll-up, purchasing, master production scheduling, and of course the MRP program. The MRP program being the brains and the central program of all of these modules working together really helped define the term of these programs. They just called them MRP. And we were an MRP company. In the 1980s, MRP evolved into MRP2. This is where I founded my first company, for example. This is where you integrated the accounts receivable, accounts payable, general ledger, and sales order management with all those manufacturing modules, all those MRP modules. In point of fact, the product name of my very first product was called Infamax, Integrated Financial and Manufacturing Control Systems. And there were other MRP2 companies as well. And then in the 1990s, MRP2 evolved into ERP. And again, this was manufacturing centric. It's well known that Gartner coined the term enterprise resource planning in the early 90s. Actually, it was an individual, his name was Lee Wiley, who was the CIO of Gartner at the time. And Lee had just come out of General Motors, where he actually helped to build a custom package for GM in the Saturn plant. And he looked at the whole organization, and that's where he said, you know, we ought to coin this enterprise resource planning because we're going to take care of the whole enterprise. That's what's going to be going on in the 90s. In point of fact, there was a Gartner chart in 1998, and I'm sure you've all seen the Gartner charts with the magic quadrants. Well, up in the upper right hand, there was SAP, Bond, Oracle. These are names you're familiar with. There was J.D. Edwards. There was a number of companies that were on that Gartner chart. All of them were either manufacturing or distribution except for a few. And one of them was PeopleSoft. So this is where the term ERP started to change to be more than just manufacturing or distribution, because PeopleSoft was basically an HR company. And it serviced other than and more than just manufacturing and distribution. And in the 2000s, we're going into the cloud. So it's really the same functionality. There are some new modules and some new manufacturing processes, a lot more outsourcing going on these days. But for the most part, going to the cloud means really redesigning this software so that it is multi-tenant, best of breed, can be accessed anywhere at any time, mobile, has embedded analytics. And of course, there's a changing role of IT because things are now no longer on-premise. So now let's get into a little bit more detail about MRP and ERP. And I'd like to turn this over to David Bush. David.
Thank you very much, Pat, for that very interesting and certainly helpful history lesson on the evolution of manufacturing systems. We're going to be using a lot of that information as we continue through today's webinar and also in the future webinars, so it's going to be very, very valuable. During my part of this webinar, in fact, I'm going to be referring back to several of the things that Pat said, and in particular, I'm going to be focusing on the similarities and the differences between the older MRP systems and the current ERP systems. For many years, the ability to use a computer to assist with manufacturing planning has been recognized. Those early material requirements planning systems really helped buyers and planners to figure out, order, and maintain the correct amount of material components that were necessary to satisfy the manufacturing process. They used the balancing of supply and demand. Supply being the material that is coming into the manufacturing facility, probably through mainly purchasing and also through manufacturing sub-assemblies, lower-level assemblies, and other components, and demand being customer orders that require these things to be shipped out of the company, out of the factory, as well as other work orders that require material and sub-assemblies in order to build the product. The supply and demand were planned by the system so that inventory levels would be controlled to meet but not overly exceed demands. So costs as well as production was being controlled. But as time went on and these new tools were being used, it became very clear that more tools were needed to help plan way beyond the control of just material. So in fact, enterprise-wide planning was needed, and that led to the creation of our modern ERP, Enterprise Resource Planning Systems, that include the ability to plan and control not only materials, but machines and departments and finances and many other entities that a manufacturing company relies on to move product out the door and to their customers. The best ERP tools that are available today actually closely mimic the thought processes that human planners use when they're looking at a company's resources. It's been said that information is king. Well, information certainly is king to a planner. He needs as much information as he can possibly have in order to plan material and other considerations properly. So let's consider how this works when we're planning material requirements. Let's focus on just that one area. In its simplest form, material planning is simply the process that a planner goes through to be sure that the right amount of material is available at the right time. But there's many other considerations that have to be taken into account that are involved in those decisions. It might sound simple, but it's really very complicated. For example, what is the right amount of material that should be brought in? Well, the bill of material that Pat talked about in the earlier presentation indicates not only what those components are, but also the quantity of any single component that is required to build a parent. So let's take a look at that bill of material slide again, but this time with a small addition. So you notice that to the right of each component in this bill of material, there's now a number in brackets. That number represents the total quantity of that item that is required to build a single bicycle. So at level 0, our top level, the parent item, bicycle, obviously we're building one, we need one bicycle to ship to our customer. Going down to level 1, that bicycle is made up of one frame, 2 wheels, 1 transmission, which may be the gearbox assembly, 2 controls, which might be the brake assemblies, 1 for each tire, and accessories. There's no number next to accessories, and we'll get back to that in just a minute. You'll notice the second level down on this bill of material is the wheel assembly. The wheel in this very simplified picture is made up of 256 spokes, 2 tires, and 2 rims. Those 256 spokes are divided between the 2 tires. So a planner would need to look at all of that information, compare it with inventory he already has, and decide how much does he need to buy in order to build this bicycle. But planning is very easy when you're building one of the parent. What happens when more than one parent is needed? Recall that a parent is the item that is going to be shipped to the customer, and the subassembly and purchased components are the parts that go together to make up that parent assembly. Well, the quantity per, If we could go back to that previous slide for just a minute. The quantity per is multiplied by the quantity of the parent item that's being built. But that's not always even as simple as that might seem. Because think, for example, about paint that's not even on this bill of material chart that's needed to paint the frame. If you're only building one bicycle, you might need 1 pint to prime the spray paint machine and also to paint that one frame. But what if you're building 100 bicycles? Does that mean you need 100 pints of paint? Well, clearly not. And a planner would need to know exactly how much further that paint will go when multiple units are being built. In addition, going back now to that accessories box, well, the quantity of accessories may be determined directly by the customer sales orders. So by accessories, you might think of things like a light mounted on the handlebar. You might think about reflectors or a horn or things like that. And those accessories requirements are driven or may be driven directly by customer orders. However, this planner may be building bicycles to stock to ship at a later time when orders do come in. So he may have to decide based on historical information, other information that's available to him, how many bikes need what accessories so that he can plan that material completely. So as options increase, it becomes very clear that the complexity of the material requirements planning becomes much more complex. Now, other things that need to be discussed and need to be thought through would include things like scrap. Will there be any scrap produced during manufacturing that needs to be accounted for? Is the bill of material quantity just for one individual parent item, or is it for the entire order, regardless of the quantity that's being produced? For example, you might think about a special tool or a fixture that might be needed to hold the tire rim while the spokes are being put on. Well, only one special tool or fixture would be needed regardless of how many bicycles are being produced. Will the components be needed for other items being built at the same time? The spokes, for example, might be the same on several different models that are all being built simultaneously. So the planner would have to think about not how many spokes do I need just for this one bicycle, but he needs all the information, the big picture that tells him across all of the things that we're building, how much of this item do I need. So another thing to consider is timing. What is the right time? How do you calculate the correct time for material availability? Well, that also may seem on the surface to be a simple thing to figure out. We know it takes a week to build the bicycle, so we need the material here the day the bicycle is released to the shop. Well, obviously, the material needs to be available when the order is released to production, or does it? Perhaps this particular component that's being planned won't be needed for several days. Or if it's a very complex structure that's being built, it could be weeks or even months after production begins before this component is needed. So is there additional time needed to inspect the item when it comes to your manufacturing facility? Maybe to test it before it can be made available to production? And how long is the vendor going to take to get it to you once the order is placed? There's also financial considerations that have to be taken in view. Is there an economic order quantity that should be reviewed? Oftentimes a vendor will say, well, I know you order 10 of that item, but if you order 25, the price will go down significantly. So the planner has to think, well, will I use that 25, or is it possible that they might be damaged before I get around to using them? Is it worth it for me to save that little bit of money? Maybe it is, maybe it's not. How can the ERP system help engineers, planners, buyers, and others to handle all of these overlapping issues? Well, it's accomplished by providing information. information, again, is king. By breaking down the problems that the planner is dealing with into manageable functions that allow the system to systematically work through each requirement in a way that, once again, mimics human reasoning. So, for example, let's consider how a human would decide how much of a component to order. Well, first, the buyer needs to know how many of the component is needed to meet the demand, and that's what the bill of material that we just looked at earlier showed. In part, the number of any given part or subassembly that's needed to build the parent or that top-level item. The planner would typically multiply the bill of material quantity of that component times the number of the parent items being built, so he would have the raw quantity required. But as we've already discussed, that number might need to be modified by many different factors. For example, considering the number of pieces that could be lost during production, including setup quantities and scrap for various reasons. That information generally comes from engineering, and we're going to be covering that in a future webinar, how an ERP system can take that into consideration. But that information will tell the planner that X number of pieces are going to be lost during setup, percent is going to be lost during production, and so in planning quantities to buy, the planner will have to increase raw demand by those percentages or those quantities. But what about other requirements for the same component? Remember I mentioned earlier the spokes, for example, may be used on many different models of bicycles that are being built at the same time. Well, the planner is going to need to know how many different orders require that same item. And if so, when are those other orders due to be produced? And should the purchase order quantity for the component include those requirements? Will they be needed at the same time as the first requirement? Or should they be scheduled to come in sooner or later? Can all of the demands be combined into one order to get a better price? And even if there are no other demands, should more be ordered to meet a minimum order quantity from the vendor? What are the various pricing levels? If you buy X number, you get it at this price. If you buy the next level, it's a lower price. Clearly, a lot of information is needed to plan correctly. And in an ERP system, all of this information is being fed into that engine, and then detailed information is being provided to the planner in a way that he or she will be able to meet the demands. To complicate the process even further, there's a lot more needed to produce an item than just component material. Consideration has to be given to things like, say, machine time in production. Are the work centers to build that final item available when they need to be in order to meet the customer's due date? Are there any revisions or engineering change orders that are going to affect production? Maybe, for example, the handlebar has been remade by engineering to solve some problem that had come up in the field. Well, what happens to all of the old handlebars that had been purchased and are sitting in stock? Are they going to be used up, or are they going to be scrapped? Information like that has got to be available to the planner. Resources, including personnel and cash flow and shipping and receiving schedules, may need to be considered. Think about cash flow just for a moment. All of this material coming in has to be purchased. Where is the money coming from to pay for all of those components? Perhaps in some cases the customer will be supplying money in advance to partially cover the costs. In larger companies, the companies themselves may cover those costs, the costs of inventory, realizing that they will not be paid back until the product shipped at some future time. But that certainly is something that has to be considered. The ERP system is going to help planners also know the shipping and receiving schedules. Should they plan on material to come in on a specific day and then find out later that shipping or receiving is closed on that day? So even minute details such as that have got to be considered. So the ERP system is going to present the information to the planner in a way that is both easy to understand and at the right time. All of these factors and many, many more go into the successful execution of a manufacturing plan. But now I'd like to invite Pat Garrity back again to discuss the specific components that make up the ERP manufacturing system. Pat.
Thank you, David. So I'll be very brief. What goes into a modern end-to-end ERP? So I'm going to look at this from a software standpoint. So there's a number of ways to depict an ERP system for a manufacturing or distribution company. There's module charts or process and business flows. And I thought for today's webinar, this is what we'll use, which we call a subway map. I actually grabbed it from Rootstock. I'll briefly go through some of the points on this process flow. You're familiar with them now. There's CRM, there's configure price quote, there's a sales order, there's engineering, master production scheduling, MRP or DRP, purchasing and receiving, scheduling, capacity planning, inventory warehouse, time and attendance. We've got accounts payable, general ledger, and accounts receivable, order fulfillment, service and repair, RMAs, cases, things like that. And this is one way to look at an ERP system. Now, one can complete the picture, because what I just went through was basically an MRP or ERP system of the 90s. Now when thinking of the best of breed approach, not only can you have a best of breed of financials, such as accounts payable, general ledger, and accounts receivable, but you can also have HR and payroll. You also add CAD and a PLM and PDM system. Quality management can be hooked into the ERP, transportation management, and many other best-of-breed components. So to wrap it up, this is a software depiction of a contemporary best-of-breed ERP system of the cloud. And now we'll turn it over to questions and answers.
Thank you, Pat and David. That was impressive. Before we go to your questions, just a quick reminder, this webinar will be posted on our website at www.rootstock.com. And of course, after the webinar, if you have any further inquiries, please email us at marketing@rootstock.com. We'll now answer questions submitted during today's presentation, as well as take any new questions. And just a reminder, you can still submit questions through the questions pane in your attendee control panel. Our first question today is, what alternatives are there to ERP? If I was trying to decide on whether to take on the expense and work involved in setting up and maintaining an ERP system, what other options are there? David.
The main option is continuing to use the old systems, for example, Excel spreadsheets, in an attempt to keep track of all the information that's needed. Some companies have been successful in doing that, but typically it's very, very small companies that have very little information. In today's manufacturing world, there really is no alternative than using a good ERP system.
Okay, we have another question here. Why choose one ERP system over any other? Aren't they pretty much all the same? David?
When looking at ERP systems, something that must be kept in mind is that each one has a niche. It might be very, very strong in one area and not quite as strong in another. So you want to be very careful in making sure that the ERP system that's chosen handles distribution very well, for example, or handles complex manufacturing very well. It just takes a lot of effort, a lot of work to make a a good decision. Looking at the ERP systems that are available today, probably the more mature ones, the earlier ones, are going to give you the type of functionality that is really needed. And typically you want to be more careful of the newer systems that may not be fully fleshed out yet. So just do your homework and look carefully at your company's requirements and compare the ERP system's ability to meet those requirements.
Very good. We have one more question for today, David, and the question is, if I don't do any manufacturing, but only distribution, procurement, and delivery, do I need an ERP system?
I think Pat really touched on that in his initial presentation today. These ERP systems that we're discussing in this webinar are for manufacturing and distribution. So yes, distribution can be extremely complex. If what you do is simply buy material and ship it, even that can be very complex depending on the varieties that are involved, the options that your customers have, things like that. So yes, modern ERP systems are designed for both manufacturing and distribution companies because they're needed.
Okay. I think we have one other question here. What is the benefit of module type ERPs versus an all-in-one solution?
I kind of think we're talking about the same thing here. Module type ERP systems work seamlessly together as if they weren't different modules. And that's something that, again, that you'd want to look at very, very carefully, is how well are those modules integrated so it is seamless. I'm not aware of any system that is not a module based. So any ERP system you look at is going to have been built, for example, purchasing is a module, engineering is a module, sales order entry is a module. All of these things have got to work together seamlessly, or else there's far more work involved, far more opportunities for mistakes being made. Missed information can make the difference between a successful sale and an unsuccessful sale. So I don't know if that completely answers the question, but I think that basically you want to look at all of these systems as integrated modular systems.
Very good. And our final, we had a question here saying, I really like the final flow diagram showing the functional interconnections. Is it available for reference somewhere? We will be publishing these slides and our webinar on our website, so you'll be notified of that. And I think we'll wrap up our Q&A here. And before we end today's webinar, I'd like to present a brief look ahead at the upcoming topics in our ERP 101 webinar series. Today, we covered an introduction to manufacturing and distribution. The next webinar in the ERP 101 webinar series by Rootstock Software is scheduled for August 16th, and will cover the topic engineering. Learn how to create part master records and bills of material. Future webinar dates are to be announced. Thank you very much for joining us today. We look forward to seeing you at our next webinar. Today's webinar is now over.